trig functions right now. They're graphing them. And I said, okay, you guys, you wanna start learning about graphing because you see it in calculus, you see it in science, and then you got simple harmonic motion, which is part of the graphing of these curves. Notice the phrase simple harmonic what? Why was calculus invented? To explain what? Motion. All right. Now, here's a graph that represents the height of a mass at time t, and it's oscillating, typo right here, at the end of a spring. It's a very, very famous, simple harmonic motion setting and environment here, right? This is actually, it could be vertical up and down, or sometimes they put a wall there. And here's your spring. It's going back and forth. That's the traditional sort of oscillation called simple harmonic motion, meaning you assume that there's no resistance, that this will oscillate forever. So it's oscillating forever, which is why you have the sine curve that oscillates forever. Doesn't really happen in that real life. It's really dampened, but okay. The position function is given to you this way. And you go, what are you talking about? That's a trig function, ladies and gentlemen. S to t is now 300 plus 40 sine t. Represents the simple harmonic motion. What do they want you to determine? If we read this, what do they want? The position. What else? Velocity. What else? Ooh, let's say acceleration. I'm going to have to change that when I get home. And what? We'll say speed. We'll answer the speed question. But I also want to add acceleration as well. So I'll do that here. When t is what? Pi over 3 seconds. I might want to reword everything. Okay, I'm going to correct that in typo. What does that really mean? It means the position function is s of what? Pi over 3. Velocity is v of what? Pi over 3. Speed is the absolute value of what? V of pi over 3. What's my acceleration? A of pi over 3. So I'm probably going to add some more language to this stuff to make it something that I really want you guys to do. The question's going to be, though, let's answer this. How do we do it? Do you guys know? You start with a position function. Your position function, s of t, is what? 300 plus 40. What is that? Sine t. How do I find the position of that mass when your time is what? Pi over 3. Do you guys know how to do that? You just plug in what? Pi over 3. So you get 300 plus 400 sine 40. Thank you. Sine pi over 3. Anybody happen to know what is sine pi over 3? And that's 60 degrees? So, Mr. Judge, why are you doing all the detail? Because we're learning, we're reviewing. Is that right? Special triangle. 2, 1, square root of 3. What is sine of that 60, which is pi over 3? Isn't that the square root of 3 over 2? So this here is square root of 3 over 2. What does that mean? The position is 300 plus 40 square root of 3 over 2. Or, what is that going to be? 300 plus 20 square root of 3. So, a lot of times in science books, and I guess that might be in centimeters. I don't remember. Did they tell us? Yeah, centimeters. And let me kind of write that a little clearer here. It kind of bothers me. I can always tell when my blood sugar is low or high. It shows up in my writing. It's a motor skills issue. And, if you wanted the numerical answer, uh, 20, yeah. Let's go back. 300. Told you, motor skills. 20 square root of 3. Okay, approximately, if I go to the tenths, 334 point what? 6 centimeters. That's your position function, pi over 3. So a lot of times people will accept both the symbolic answer or the numerical answer, but you might see a symbolic answer in a lot of science books. They like to do that. Okay, they don't necessarily go the numerical, but they expect you to be able to know both. Now that's just the position at that time. How do we get the velocity? Well, what do you do with velocity? The definition of velocity is the derivative of the what? Position function. So what was that position function? I think it was what? 300 plus what? Was it 40 sine t? Yes, it was. What's that derivative going to be? Do you guys know? Is it 40 cosine t? So now you need what? This function. That's called the velocity function. And they want the velocity at what time? Pi over 3. So you're going to have to get this function. And it's cosine now of pi over what? 3. And you guys know pi over 3 is really what? 60 degrees now. And what's cosine of 60 if I go back and look at this picture? Isn't it 1 over 2? Your 60 degree right here. Do you guys remember special triangles? It's adjacent over hypotenuse, 1/2. So, not bad. So it's times 1/2. What's 1/2 of 400? It's 200. Okay.
It's 40.
Sorry, was it 4? I keep putting that 100. Oh, look at that. Thank you. So what is this? This is constant what? Velocity. And that will be, the units will be in centimeters per second. Okay, so I'll put the units down here too. That's what they want. They want to know, oh, that's 20s. What's the speed? Remember what I said the speed was? Absolute value of velocity at that moment there. And so if I know the absolute value at 20, what's that going to be? My speed, ladies and gentlemen, is 20. Okay. All right, what's the acceleration now? Well, a of t is the derivative of the what? Velocity. What's the derivative of my velocity is what? Is that 40 cosine t? Is it negative? Well, hold on. We gotta put 40 cosine. That's the definition of what? Velocity. What's this derivative? Negative 40 sine what t? Is that true? So it isn't too bad. I don't think it's that bad. Taking derivatives, that's why we are here. But they also want to know, this is your acceleration function. What is a of pi over 3 going to be? That's negative 40 sine of what? Well, and that's again 60 degrees. Do we know what that was? I think so. We said that was the square root of 3 over what? 2. So that one picture went with all three of these answers. Okay. Ladies and gentlemen, this is the acceleration. Units of acceleration, though, are going to be in what? Centimeters per second squared. But this is why you care about the math, to talk about what? Motion. Whether it's motion due to an arbitrary function or motion due to trig functions. And this is now related to those students that took, trig, where you have simple harmonic motion. They're pretty much only asking you for S of t in those, but now calculus comes along, they want V of t and A of t. And then here's an even better question. Let's see if you're awake. Let's put it all together. Is the particle slowing down or speeding up when t is pi over 3? What do you guys have to know? Tell me the velocity. Tell me the acceleration at those instants, pi over 3. What was the velocity? 20 meters per second. Is that right? What was the acceleration? Negative 20 square root of 3. Meters per second squared now. What's the answer to this question? Slowing down. Outstanding. Did you guys see how we put all this stuff together? Why do I know at that instant, at that time, t being pi over 3? You plug that in, the function. How do we know it's slowing down? Because in one case it's positive, and in the other case it's what? It's negative. If they're opposite signs for velocity. Remember, velocity says this particle is moving to the right. However, the negative acceleration means it's being pulled to the what? to the left, the negative direction, backwards, if you will. So because they're opposite in sign, that means the particle is slowing down at that point. All right, you guys good with that one? It's putting everything here together for us. So I might modify that stuff when I get home. Oh, it's not like I don't have enough to do. But hey, I think you guys are worth it. And if you don't want to listen to me, look at chat, look at Math GTP. Maybe that'll help. All right, you guys okay with that? So they can do this all day long. They can change the function, you know. Number 2, that's what I did. Number 3, change the function. Oh, what time is velocity equal to 0? Oh, maybe we should ask those. We'll see. I didn't ask that for the first one though, but whatever, the first 2. No, I didn't. Okay. Should we try another one? You guys ready to try another? Nope. What's your position function now? See the position function? What's the time now? Pi over 4. They want here S of pi over 4. They want what? V of pi over 4. They want the absolute value of V of pi over 4. And then they want A of what? Right? Because what are they asking for? Position. Okay. Velocity. Okay. Speed. Oh, absolute value of velocity at pi over 4. And although I didn't put it there, I'm going to later. We'll put acceleration. At pi over 4. All in the homework called higher order derivatives in the book. All right, let's get going. Here we go. My S of t becomes, let me answer, 250 plus what? 30 cosine t, is that right? And so if I plug in for t now, pi over 4, 250 plus 30 cosine pi over 4. Do you guys happen to know what pi over 4 actually is? It's 45 degrees, is that right? And that's kind of good to know. You say, why is that good to know? Because cosine and sine are both going to be what? Square root of 2 over 2 or 1 over the square root of 2. So some of these are pretty easy to answer because it's not going to give you what? Some scary, really, values there. This would be 15 now, square root of 2. Okay? They want these things here. So this is the first answer they want. Okay, and I guess that's going to be in centimeters so that those science instructors don't get angry and say, oh, that Mr. Judge. Centimeters. Okay. We want velocity now. So velocity is the derivative of what? The position function. I know the position function is 250 plus 30 cosine t. What is this derivative? Is that minus 30 sine t? Okay, good. Look at that. So I need that function because I want the velocity at pi over 4. Remember, that's a radian value, by the way. And like I said earlier, if you wanted, you look at this, I didn't draw that, but, for 45 degrees, this is 1 square root of 2. So you use your definitions of sine and cosine kind of from geometry. Negative 30 square root of 2 over 2. V of pi over 4 becomes negative what? 15 square root of 2. It's what they're looking for. And the units of velocity are meters per what? Second. Yeah. Oh, centimeters. Let me go back. These are in centimeters, yeah. So my velocity is negative at that time. Let's find now what's the next we got to find? What's our acceleration? Well, the derivative of what function? Okay, so get the velocity function, differentiate that. That's not minus 30 sine t. Is that right? I know I moved pretty quick there. Is that right? There's your velocity, negative 30 sine t. What's this derivative? Yep. That's the function we're looking for. All right. But what they also want is what's acceleration when your time is pi over 4 seconds. Cosine 45 degrees, we know again, is square root of 2 over 2. So this becomes negative what? 30 square root of 2 over 2, which gives you negative 15 square root of 2. So you got your acceleration, ladies and gentlemen. And the units are going to be meters per second, centimeters per second squared. And I want to notice something about these two, okay? Here's that going to be that following question. Speeding up or slowing down at time what? T is pi over 4. Okay. What's your velocity? It's negative. What's your acceleration? Same sign. What does that mean? Speeding up. And there you guys go, man. What do you think? Boy. Because both velocity, they have the same sign. Is that right? I mean, I do know velocity is negative, acceleration is negative. That's what it means to speed up. It's putting everything together. So I don't know. How do you feel about it coming together now? Does that seem like it's hard and impossible to do? Okay, we're going to go over question number 6. They're giving us the position function where t is going to be greater than or equal to 0. Okay, always. 4 position functions, and they want us to determine the position. And if we go back and try to take a look at the colors, I guess velocity is orange. Want us to find the position, velocity, speed, and we added here acceleration. All when the time value is 5/6. So they're saying, hey, what is S of 5/6, V of 5/6, the absolute value of V of 5/6, A of 5/6. Position, velocity, speed, acceleration, all at the time value of being 5/6. All right. So our position function is 4 cosine t. So let's write this down. Cosine pi t. So now t is simply the value 5/6. So S of 5/6 becomes 4 cosine pi of 5/6. And we know this here as really, here's our t, 5 pi over 6. So let's recall, pi over 6, I believe, is 30 degrees. So 5 times 30 will be 150. So I'm going to label this here 30 degrees. This is really 150 degrees. Okay. So we need to know what's cosine of 150 degrees. All right. Region 1, Region 2, 3, and 4, all students take calculus where 150 degrees is in quadrant 2. Quadrant 2 here, sine is positive. So this is what we mean by sine. That implies cosine will be negative. So cosine of 5 pi over 6 is negative, but we have to look at the quadrant 1 answer here. I'm going to change colors. Okay, quadrant 1 now. It's our reference quadrant. All right, cosine of 30 degrees. We have to go back and remember our special triangle that we've been working with here. Okay, the 30, 60, 90. And there we go. I'm going to copy this, bring it down. But the angle is 30 degrees now. It is not 60 degrees. So your 30-degree angle is here. The definition of cosine is the adjacent side divided by the hypotenuse. So cosine of 30 degrees, which is represented by pi over 6 in radians, tells us cosine of 150, or 5 pi over 6, is actually negative square root of 3 over 2. So let's use that information now to say you're negative square root of 3 over 2. So the position function at 5, 6 is 4 times negative square root of 3 over 2, which is negative 4 square root of 3 over 2. Okay, and I think that's still in centimeters, by the way. So, okay, there's our first answer. We now need to differentiate the position function. Okay, so if our position function is going to be 4 cosine pi over t, velocity is the derivative of the position function. This is our definition. So we're going to differentiate 4 cosine pi t, which means you get 4 sine pi t. Don't forget to multiply by pi because you're using chain rule here. So this is 4 pi sine pi t. Here's our velocity function. But they want to know, what is the velocity when your time is 5, 6 seconds? This is in seconds again. So they're asking for v of 5, 6, 4 pi sine pi 5, 6, which will give you 4 pi sine 5 pi over 6. Okay. So we need the value again now of sine 5 pi over 6. In order to find that, we need sine of pi over 6, and this will be a 30-degree angle. So sine of 30 degrees. Now, sine, again, is going to be opposite over hypotenuse, which is 1/2 now. So this equals 1/2. But the angle really is 150 degrees here, because it's 5 pi over 6. Again, we can look back at this picture and we know that in quadrant 2, for sine of 150 degrees, sine is positive. All students take calculus. That just simply means that the answer is the same here. It is a positive 1/2. So we can replace this here with 1/2. And we now get 4 pi times 1/2, which is actually just 2 pi. Need more space. 2 pi. This is velocity, so I believe it's in centimeters, right? Centimeters per second. So that's v of 5 pi over 6. So, ladies and gentlemen, there you go. Velocity, by the way, is positive, so it's being pulled to the right. I'm just going to kind of label this for us, and I think we used a different color. I think it was orange. All right. Just want to mention your velocity is positive. It's being pulled. I'm sorry, it's not being pulled. It's moving in the positive direction, which is right, or forward. Okay, 2 pi is positive now. All right. Let's get acceleration. So your acceleration now is the derivative of velocity So let's differentiate your velocity function. 4 pi sine pi t. Now the derivative of sine is cosine. We pull out the constant. Don't forget by the chain, this is times pi. So our acceleration function becomes 4 pi squared cosine pi t now. All right, we need to know the acceleration when the time value t is 5-6 seconds. And so we have to know the value now, again, here of cosine of 5 pi over 6. I think we know that already. We already had that answer. Cosine 5 pi over 6, yes, we do. It's negative square root of 3 over 2. We already answered that. So we have negative square root of 3 over 2. So you get 5 pi squared times negative square root of 3 over 2. And simplifying here, this is 2. We get negative 2 pi squared square root of 3, which is acceleration at 5-6. And that should be in centimeters per second squared. 2, there you go. And I guess that's purple. So ladies and gentlemen, there it is. I'll send this to you guys, and hope you guys enjoy this.